Good morning, fellow classmates, Mr. Dosseli. Today, Miss Pap and I, Mr. Abraham, will be exploring the VSEPR theory with you guys.
Introduction. Have you ever observed all the different forms of molecules? VSPR theory has the solution. We will take a part of the valence shell electron pair repulsion theory today and talk about how it helps in the determination of molecule geometry.
The importance of VSEPR. The valence shell electron pair repulsion theory predicts the shape of molecules by minimizing repulsion between electron pairs. The purpose is to determine molecular shapes which affect chemical behavior, properties, and reactivity.
Electron domains. The definition is the areas around the central atoms where electrons are likely to be found, including both bonding pairs and lone pairs. Purpose. It helps that determine the number of regions where electron repulsion occurs, which influence molecule shapes.
Bonding pairs. Bonding pairs are shared pairs of electrons in a covalent bond. They form stable bonds between atoms and help shape the molecule structure.
Lone pairs. Lone pairs is unshared pairs of electrons that are not involved in bonding. The purpose is to lone pairs exert stronger repulsion than bonding pairs, significantly influencing bond angles and molecule geometry.
Bond angles. Bond angles are the angles formed between two adjacent bonds. The purpose is to determine the overall geometry of the molecule and how atoms are positioned in a 3D space. Over here on the bottom shows a graph of all the like type of shape and bonding angles and the angle like they occur at.
Molecule shapes. Molecule shapes is the 3D arrangement of atoms in a molecule based on VSEPR theory. The purpose is to predict how molecules interact, their polarity, and their chemical behaviors.
Molecular geometries. Linear. Atoms are arranged in a straight line. Trigonal planar. Atoms positioned at the corners of an equilateral triangle. And the tetrahedral are four atoms symmetrically arranged around the central atom.
Octa Octahedral, six atoms symmetrically positioned around a central atom. Trigonal, three atoms in a plane plus two above and below. Bent, V shape due to lone pairs.
Over here are the examples to the molecular geometries, and over here for linear, we put CO2. For the trigonal planar, we put BF3, and over here is like the figure of it. And for the tetrahedral, we put CH4, one carbon with four hydrogens surrounding it.
Now we have for the octahedral, we have the CSF6. Trigonal, we have NH3, and for bent, H2O. H2O is water, as you can see.
For the conclusion, we want to end it off with the VSEPR theory, which shows that molecule shapes are determined by electron pair repulsion, and these help us understand how the shapes is key to predicting a molecule's properties and behavior, making VSEPR theory essential in chemistry and real-world applications. Thank you for listening.
Thank you for listening. Mr. Abraham and Mrs. Pop will be here for you guys if you have any questions.
Yes.